Okay, let's start things off with an absolute disaster. Home Health of America's CEO mandated a big bang go live for their brand new electronic health record system. His big strategy? Launch it on a Monday. Now, Monday is their absolute busiest day of the week, but he figured, hey, if the system can handle Monday, it can handle literally anything. Well, the result was a massive system-wide failure. Functionality completely broke down, cellular connections kept dropping in patients' homes, and digital documentation slowed to an absolute crawl. The staff's overtime actually doubled, patients went entirely unseen, and management was ultimately forced to abandon the new system and fully retreat back to paper records. So how exactly does a massive, incredibly expensive project end up in such a catastrophic failure?
Welcome to today's Explainer. Today, we're tackling system implementation averting disaster. This is that heart-pounding stage in the system development lifecycle where the rubber finally meets the road and a new technology is officially launched. I'm going to guide you through the exact details of this chapter so we can learn to prevent catastrophic failures like the one we just talked about and ensure your next rollout is incredibly smooth.
Okay, let's dive into this. We've broken this massive textbook process down into 6 logical phases: the implementation challenge, preparing sites and users, customizing the system, testing and training, data conversion, and finally, go live and beyond.
Let's kick things off with Section 1, the implementation challenge.
Think of these upcoming steps as the essential, absolutely non-negotiable blueprint for your entire project. It's really a laborious 12-step mountain, climbing from site preparation all the way down to go live. And this perfectly illustrates why we can't just, buy a software package and skip straight to the end. While some of these steps can definitely happen concurrently, many of them strictly depend on the previous one finishing first. I mean, think about it. You simply cannot install software if the physical hardware hasn't even been installed yet.
Moving right along to Section 2, preparing sites and users.
That logical progression leads us straight into the crucial groundwork phase. A brilliant new information system is genuinely only as good as the physical environment it lives in and the actual people who have to use it every single day. So it really comes down to 2 totally distinct types of preparation. On one side, you've got site preparation. This could mean major physical renovations, running miles of new networking cables under the floor, or literally just making sure you have enough electrical outlets to plug the new hardware in. If you overlook that, your project is delayed on day 1. But on the other side, we have user preparation. And this is deeply psychological. Users naturally fear change. They might fear their jobs are going to be replaced by the system, or actually on the flip side, management might have hyped the new software up so much that users have wildly unrealistic expectations about what it can actually do. Both the physical building and the mental state of the staff absolutely must be actively managed.
Which brings us to Section 3, customizing the system. Once your environment is prepped, off-the-shelf software has to be meticulously tailored to a healthcare organization's incredibly specific needs. Now, what's really interesting about this comparison is the dramatic difference between good and poor user interface design. A good screen has a clear, descriptive title, logical sequencing like, putting the street address, city, and state together, and clean alignment. A poor design is cluttered, completely lacks a title, and the data fields just sort of jump around randomly. Proper visual alignment might seem like a tiny detail, but in a fast-paced healthcare setting, this dramatically reduces user eye fatigue and actually prevents really serious data entry errors.
But customization isn't just tweaking the software to fit your old habits. Actually, scratch that. It's often about entirely blowing up your old processes. Enter re-engineering, taking a hard, ruthless look at how the healthcare organization actually does business in order to massively improve efficiency.
Implementing a new system is the absolute perfect, albeit a little intimidating, time to ask this really provocative question. Why do we still do it this way? Literally every preconceived notion and daily task has to be challenged. So often employees do things a certain way just because, that's how it's been done for years, and they're terrified to stop. Overcoming that deep comfort with the status quo is absolutely essential if you want to maximize the actual benefits of the new system.
All right, Section 4, testing and training.
With our processes completely re-engineered and our screens designed, we enter a highly cyclical phase of catching errors and preparing the human element. Listen, you cannot simply force a professional adult to sit in a computer lab and expect them to blindly absorb information. The training has to be rooted in adult learning principles. Adults need to know why they are learning something. They're experienced, they need to see relevance, and they like being responsible for their own decisions. So whatever you do, don't teach a nurse a complex system function that only the billing department will ever use.
If the training doesn't tie directly to their immediate relevance in daily tasks, they simply won't be motivated to learn it.
Now, while users are busy training, rigorous testing is happening simultaneously behind the scenes. We're talking interface, integration, and volume testing to see if the entire network crashes when hundreds of people log on at once. This cycle relies heavily on the trouble ticket. It's a highly detailed form used to document every single bug so the project team can replicate the error, resolve it, and then, this is the critical part, retest it. Because fixing just one line of code could very easily break something else entirely.
Moving right into Section 5, Data Conversion. Now we hit a massive technical hurdle. An organization obviously can't just ignore its historical patient data. It all has to be moved from the old system into the newly formatted one. And this brilliantly illustrates exactly how data mapping works in the real world. Let's look at the health record number. The old system stored this as a 9-digit number, right? But the new system absolutely requires 12 digits. So a specialized conversion program has to be written to automatically add 3 leading zeros to every single record being moved over. It's a literal before and after mapping that takes incredible planning to ensure absolutely no patient data is lost or corrupted during the transfer.
And finally, Section 6, Go Live and Beyond.
This is it, the ultimate high-stakes phase where the switch is officially flipped, an event that's usually scheduled during the absolute quietest night shift possible just to minimize disruption. So, the crucial point is how exactly leadership chooses to flip that switch. You've basically got 3 go-live models. The phased approach rolls out one module at a time, like, say, starting with just medication ordering. The pilot method implements the entire system, but only in one specific nursing unit first. Both of these are safe, incremental approaches. And then there's the Big Bang method. This is where the old system shuts off and the new one turns on everywhere all at once. Remember our opening case study? Yeah, that is the exact highly risky strategy that completely doomed Home Health of America.
Directly tied to those go-live models are your turnover strategies. Straight turnover means you immediately cease using the old system. Now, it's cost-effective because your staff isn't doing the work twice, but man, it is incredibly risky if things suddenly go wrong. Parallel processing, on the other hand, means you run both the old and new systems simultaneously for a few weeks. It provides the ultimate safety net for sure, but doing double data entry is just incredibly labor-intensive, hugely frustrating for the staff, and honestly, very expensive.
But you know, even after a successful launch, the work never truly ends. Organizations then enter the evaluation and maintenance phase. They have to prove the return on investment, really evaluating if the system actually saved the money and time it promised. Furthermore, to keep things running smoothly over time, IT must continuously use a test environment. This is essentially a sandbox duplicate of the live system without any actual patient data, allowing the tech team to safely test future vendor upgrades before they ever roll them out to the rest of the hospital.
Which brings us to our final thought today. System implementation isn't just about buying some fancy new software. It's a monumental challenge that demands extreme organization, a really deep understanding of human psychology, and absolute technical precision. So what does this all mean for us? When your organization faces its next massive system rollout, will it fall victim to a rushed, catastrophic big bang? Or will it be a carefully orchestrated, perfectly prepared 12-step success? Thank you so much for joining me on this explainer. I really hope this deep dive helps you champion a flawless implementation in your own field.